share my screen. And what I wanted to discuss in my labs is somehow I thought I had deleted, not assigned, homework number 27. We are not
Mhm.
covering that content, so I'm not going to expect you to do it. Has anybody started looking at that homework 27 on section 8.8? Some
Uh,
in the other class, and because they had started it, they had asked me to leave that assignment in there as extra credit. You guys were not going to cover their content at all. It would do it on your own type of thing. Do you folks want me to leave that assignment in there as an extra credit assignment, or do you want me
Yes,
to?
please.
sure,
Okay,
sure.
and so that'll be in there. And now let's open OneNote. And I have to apologize. I did not start a notebook for today. Let's see, last class we had talked about when the final is going to be, which is December 16th, and it'll be available from 8 in the morning to 8 in the evening. And we had said that test 4, let me just double check and make sure that I am not misspeaking. I apologize. Usually I try to get all of this stuff done up for you before class begins. But as I was telling Sonia before, I got carried away with typing things for the professional development day. So I'm going to cheat and just pull off the important due dates from last class. Exam 4 will be due on December 11th by 11:59 p.m. And that date is a Friday.
Wait, when will it be available?
It will probably be available on the 9th.
Okay.
Okay. Homework 22 is due the 2nd. Homework 23 is due the 4th. The interest quiz which is in my math lab, but you have to put your stuff in the Dropbox, which Adam, thank you for reminding me to create that Dropbox.
Hmm.
Is due the 3rd. The last day that you can work on my math lab, submitting new homework, will be the 11th. And we just said that homework 27 is not required. If you want to, it'll be extra credit.
I did check, the previous exams are not open.
Okay, you know what it is? It's because in my labs, I don't want to count them to count towards your grade. So what I'll do is I'll have them count as 1% of your grade, which won't really make a difference in your grade. And once they count as part of your grade, both the tests and the quizzes, then they'll show up in the grade book and you can click on them there. Okay,
Thank you.
so I just need to write myself a note to do that.
Is this homework 27 on simple interest and percent or what?
It's on how they calculate the interest that you owe on a credit card bill. It does involve simple interest. However, you have to find the average daily balance, which is something that we are not going to take class time to do. So if you're interested, it's there. If you're not interested, don't worry about it. I wish we had the time to do it because I think that it's should be important to you. Did you ever wonder how they figured out your average daily balance, what you owe on average over the course of the month during a billing period with your credit card, as to how they figure your interest? I would love to do that with you, but it would take probably an entire class and we just don't have the time anymore. So, if I remember correctly, well, wait, sorry. I'm just messing up all over the place today. I had forgotten to ask the question I promised I'd start every class with. Does anybody want to look at any questions from the homework or anything from what we did last class? Everybody's doing all right with all of the homework?
I am at least.
Okay, then last class we left off talking about the annuities. And we said that they are savings accounts where you make regular fixed payments. Every compound period. And other than discussing them and defining them, we didn't get very far. We did give the two formulas. One was A equals P times parentheses, 1 plus R over N to the NT minus 1, close parentheses, over parentheses R over N. And we said that we would use this to find the future value if we know the payments. And the other was P equals A times parentheses R over N over parentheses, 1 plus R over N, close parentheses, to the NT minus 1, close parentheses. And we said we'd use this to find the payments needed to reach a future value. And in both of those formulas, A is the future value. P is the payment amount. N is the compounds in 1 year. R is the rate as a decimal. T is the time in years. And another thing that's a little bit different with this formula is we need to be able to find the total of the payments. And that would be each payment times the number of years times the number of payments in 1 year. And so then the interest earned here is going to be the future value minus the total of the payments. Or A minus P times N times 2. And so what is that all about? I think the Do I need to wait a minute for everybody in terms of writing, or are we ready to roll?
No, can we wait a minute?
Sure. Let me know when you guys are ready.
All right.
Ready?
Yep.
I don't know. So this is your,
So last class, we looked at a compound interest problem. And we said that if we wanted $500,000 in 30 years, and we could invest at 4% compounded monthly. We said we'd need to invest $150,898 now. And we all agreed, I think we all agreed, that coming up with $150,000 now might be a challenge. So let's instead say that we still want $500. Not 500,000, $500,000 in 30 years. Let's say we're still going to get 4% compounded monthly. But we're going to make fixed monthly payments into an annuity. What should the payments be? What's the total of the payments?
that's, oh, so,
And what's the interest earned?
okay, so.
Do I need to pause for a moment? Or are we ready to roll?
Yes, please.
Yes, please to roll, or yes, please to pause?
To pause.
Okay. I used to always make fun of my children when they were growing up because I'd ask a question, A or B, and they'd answer yes. And I'm like, well, yes to which? So I was also a very mean mother. They'd come running up to me and say, Mommy, I have a question for you. And they'd always precede their question with that. So I would always go and say, I have an answer for you, blue. Because they didn't tell me the question. So I just give them a random answer. Yes, I was a mean mom. Oh dear. And on that note, are we ready yet, folks? As I look at this wording, that 500,000 isn't what we have now, but what we'll have in the future.
okay.
Our rate is obviously 4%. Our time is 30 years. We're doing monthly payments. We're compounded monthly, so that's 12 times a year. And what we're looking for is our payments. So that's what we don't know. Because that's what we don't know, it's easiest if we use the formula that's solved for that. So we'll use the formula that says P equals A times parentheses R over N, close, over, parentheses, 1 plus R over N, close parentheses to the NT, minus 1, close parentheses. And I know that it's annoying typing all of those parentheses in, but you need them. And because it's annoying typing all those parentheses in, I'm guessing you don't want to type more parentheses in, because technically there should also be a set of parentheses around the NT. So let's, instead of typing those parentheses in, I think I had said last class, let's multiply N times T before we begin. And so that would be 12 times 30. So that exponent's going to be 360. And this is one place where I do think doing that computation by hand before we begin makes our lives a hell of a lot easier. So, substituting in, we get P equals, for A, we'll put that 500,000. Parentheses R is 0.04 over N is 12, close, over, parentheses, 1 plus 0.04 over 12, close parentheses, 360th power, minus 1. Now, what was I going to say? I was just going to say something and it just left me. I apologize. Oh, I was going to say, yeah, this is one of those things that I would not have done by hand, because think of taking this crazy decimal and multiplying it by itself 360 times. I think this is one place where you really don't want to think about doing this in pre-calculator days. We probably would have used logarithms. Does anybody want me to write out how I type it in, or can I just talk you through how I type it in my calculator?
Write it out.
Write it out?
Yeah.
So we're going to write out that 500,000. Then we're going to multiply it by, we'll open parentheses. Then we're going to type 0.04. And then I'm going to use divided by. When I use divided by, I get a slash. That makes it look like my fraction, 12. Then I'm going to close my parentheses. Then I'm going to hit that division again to get that bar for my fraction. Then I'm going to type open parentheses twice. Then I'm going to type, I apologize. Then I'm going to type 1 plus 0.04 divided by 12, close parentheses. To get an exponent with my calculator, I'm going to use the arrow up, 360 minus 1, and then close the other parentheses. Is that too small? If I shrink this down so you can see it all in one line?
No.
So once you've got that written down, let's talk through typing it in together. Let me know when you guys are ready. Ready? it's 500,000. Don't forget, you need to have 5 zeros there. One of the places where I make a mistake is, my eyes are bad. I'm sorry, it's 0. Times, open parentheses, 0.04 divided by 2. And on my calculator, that looks like the fraction 0.04 over 12, close parentheses, divided by, then I'm going to hit that open parentheses twice. 1 plus 0.04 divided by 12, and just close one of the parentheses. Then I'm going to arrow up for my exponent, 360. Then I'm going to type -1 and close parentheses. With my
Professor,
calculator, I can scroll back through and see if I typed it correctly.
my calculator won't come out of exponent mode. After I put 360 and I'm trying to put -1.
Get out of
It's-
exponent mode. I think with your calculator, you need to use the arrow right. Up at the top, there's a circle of arrows, arrow right. Will that hop you out of your exponent?
I guess, but it takes me like to the front of the problem that I have to go through the whole
Okay.
problem.
I'm gonna stop sharing for a minute, and
Hmm.
I am going to change my view. And I'm gonna ask you to show me your calculator, please. Okay, can you talk?
Yeah.
Yeah, if you use the, in the middle, if you use the arrow to the right, it should pull you. Oh, yeah, it did pull you out. So you're okay?
Yeah.
All right.
But it just brings me to the beginning of the problem.
I'm sorry. It gets you out of the exponents though, right?
Stop it.
There might be another way. You might get a quicker way looking at your manual, but I'm not that familiar with Casio.
Okay.
Okay. So when I hit equals, I am getting 720.4098,107. And again, with these, we're always going to round up. So if I were to round up, let's say to the nearest dollar, it would be $721. Okay. Now, it's not easy coming up with $720 a month for 30 years, but I do think that might be easier than coming up with $150,000 all at once. Yes?
Yeah. Okay, that's maybe.
So, how much did we pay altogether? The total of our payments. Well, we're paying $721, 12 times a year for 30 years. So that's actually going to be my 721 times that product we had before, 360. And so we're paying $259,560. So if I stand back and look at the big picture, we're putting more money in than if we put it all in at one lump sum. But we can't do that one lump sum thing. And if I want to know what the total of my interest is, it would be that $500,000 minus the money that I paid in. And so I would earn $240,440 interest. And again, that's lower than the interest I would have made if I just put all of the $150,000 in at the beginning. And you might wonder why, because it's still 4% compounded monthly. But think about it. With the other one where we just had the compound interest, we were putting that $150,000 in, all of it in for the whole 30 years. We were getting 30 years of interest on all of it. This way, only our first payment is getting 30 years of interest. Our second payment is getting a little less, and each successive payment is getting a little bit less interest because they're a month later. And if you think about it, the very last payment that we make in, it's only going to get 1 month's worth of interest, right? Because we're just putting it in a month before we, have our full $500,000. So that's why this way, for most people, it's a little bit more manageable. But you see, big picture, it's not quite as much interest and a little bit more of your money. Is everybody comfortable with that formula? Did you guys think it's feasible for you to set aside $720 a month to get that $500,000?
I guess.
Yes?
No.
No. Okay, usually college students tell me no. So let's go through and let's look at one more example. Let's say we want to deposit. How much money do you think you can afford to put in a retirement account right now every month? Anybody want to throw a number at me?
150, 200 or something.
So let's say $200 every month into an annuity. That pays, let's see, what should we use as our interest rate? Let's use 3.5% interest, compounded monthly. And should we leave it in there for 30 years, more than 30 years or less than 30 years? How long are we doing that for?
37.
For 37 years. What will our future value be? And so, with the wording of this question we just made up, we know our payments are there $200 a month. We know our rate is 0.035. Hopefully everybody's comfortable changing that percent into a decimal. We know we're making monthly payments, so that's 12 times a year. And we know we're doing that for 37 years. So N times T, 12 times 37 is going to give us 444 payments. And we're looking for the future value. This time, because we're looking for the future value, we want to use that formula that solved for A. So if I use A equals, it's P times parentheses, 1 plus R over N, close to the NT, minus 1, close, over, open, R over N, close. I want to give you guys a heads up. I go a little bit more overboard with the parentheses than the authors of the textbook do. The authors of the textbook, I don't believe, show these parentheses around the denominator, but they're assumed to be there. And if you don't type those parentheses in, you will get the wrong answer. And so I have a tendency to draw those in. And when I give you a formula sheet, those parentheses will be there. So subbing, P is 200, parentheses, parentheses, 1 plus R is 0.035 over N is 12, close parentheses. We're raising that to the N times T, or 444th power. Does everybody all right? That means we're going to be making these payments 440 times also.
Mhm.
Minus 1, close parentheses, over, open parentheses, 0.035 divided by 12, close. This time, if we type it in, we'll type 200 times parentheses, parentheses, 1 plus 0.035 divided by 12, close parentheses, raised to a power, carried up on 9, 444, minus 1, close parentheses. And that's my numerator. And if I scroll back through, it should look just like the numerator of my fraction. Then I'm going to go divide it by, then I'm going to go parentheses, 0.035 divided by 12, close parentheses. And that part should look just like the denominator of my fraction. And so, is anybody else getting 18131.1389?
That's what I got, yeah.
And so now let's look at this to the nearest dollar. And you know how when we're paying the money, we have to round up? When they're looking at the future value, you don't round up, you just round. So our future value would be $181,311 for the nearest dollar.
Okay.
The total that we pay in, the total of the payments is the amount that we pay times the number of times of year times the number of years, or it would be our 200 times, we already said that NT was 444. And so that would give us 88800 or $88,800. I guess it's kind of like amazing to wrap your mind around $200 a month for your 37 years adds up to that. Kind of crazy. Think about $200 a month. Let's say you stop and 20 days a month, spend $10 on fast food, which I know some people do. That would really add up over time, yes?
Yeah.
And so let's look at our interest earned. So we're making $181,311 minus we're putting in $88,800. And so when I take that difference, we're earning $92,511 interest. So stop. and look at it, do you notice that the interest that we earn, the money that the bank gives us for putting our money there, is still more than the money we put in?
Uh-huh.
So half of, less than half of it is our money, and more than half of it is the interest that they pay us. And it's kind of like our reward for being able to set aside that money every month. So the idea of annuity, all right, the idea of setting this money aside every month to accumulate it for savings in the future. I know back in ancient times, banks used to offer something like this. It was called like a Christmas club account. I don't think they still do that anymore because most people paid for things with credit cards now, right? But it was, back in the day when people paid cash, you could set aside so much money every week. And then at the end of the year in December, you would have money to do your Christmas shopping. And so it's called a Christmas club account, something like that. And so there's all sorts of different variations on this idea. But can you kind of wrap your mind around it's probably easier to save that big amount of money in the end if we, put aside a certain amount every month or every week or every year. And the interest accumulates differently because there's a different amount of interest actually on each payment because each payment is there for a different amount of time. I know a question that I always used to put on my handwritten test was something along these lines, where I know that certain colleges have something where if parents contribute so much money every month, it guarantees that it'll cover the tuition for their child to go to school in like 18 years if they start doing it when the kid's born, something like that. There's all sorts of accounts that kind of work with this type of idea. Everybody all right with this?
Yeah.
Okay. Where we're going next is the opposite end of the spectrum, not where we're earning money, but rather where we're paying off loans. And I think it's enough of a difference that I don't think I want to start looking at those installment loans until we meet again on Friday. Did you guys want to do one more example of one of these? Did you guys want to look at anything from the homework? Or did you guys want to call it a day?
I would be okay with another example.
Okay. In order to do another example, I'm going to ask a little bit of help. I'm going to ask you guys to help me make it up. For this example, do we want to start knowing how much money we want to set aside regularly? Or do we want to have a future goal that we want to achieve?
Future goal?
Okay, how much money do you want in the future?
$1 million.
$1 million.
Good one.
And how far in the future do you want that? $40 years? Is
I
that
would say right now, but that wouldn't work.
what?
I said I would say right now, but that wouldn't work for this.
No, it wouldn't. Let's say we can invest at interest rates right now are ridiculously low. So let's do something crazy like 2.5%, which is still high in the current market for interest rates. Although I heard on the news yesterday that Janet Yellen, who's going to be in charge of the Federal Reserve Bank, previously was a fan of gradually raising interest rates, which raising interest rates sounds like a really bad idea if you're going to be borrowing money. Like when we look in the next class at borrowing money and taking loans, interest rates on mortgages right now are about 3-4%. When my husband and I bought our first house, interest rates on mortgages were something like 15%. And the high interest then really sucked. But at that point in time, when the interest rates were on mortgages were like 15%, interest rates on things like certificates of deposit were almost 10%. Now, when interest rates are, so you earned a lot of money if you had money to invest. Now, interest rates on mortgages are really low, 3-4%, but a certificate deposit isn't even going to pay 1% interest. So you want the high interest if you're investing money. You want the low interest if you're borrowing money.
Yeesh.
I always gnash my teeth when I talk to my husband about it, because when we were borrowing money, the interest rates were high. And now that we're old enough to have money to invest, the interest rates are low. We're on the wrong side of that spectrum. But so let's say it's 2.5%. And how often are we making these payments? Monthly, quarterly?
Can we do daily?
You know what? We could try. I don't know if you'd ever find something, but that sounds like fun. So we'll
boy.
say compound it daily. What would our daily payments be?
The 360, right?
Yep. I like your creativity in writing a question. And so the future value is at $1 million. The N is 360. P is 40. So if we make daily payments for 40 years, this is going to be a big number. 360 times 40, we'll be making 14,400 payments. But we'll be living 14,400 days over the next 40 years. Banker's year, of course. Our interest is, interest is R. Our interest is 0.025, and we're looking for P. And so P equals A times parentheses R over N, close parentheses, over parentheses, parentheses, 1 plus R over N, close, to the NT minus 1, close. So we want to have $1 million. We're investing at 0.025 R over N, 360 days a year, over parentheses, parentheses, 1 plus 0.025 over 360. To the NT, their power is 14,400 minus 1. Now that one would be a royal pain to do by hand, yes?
Yes.
Yes.
Now, and again, when I type it in, make sure you've got all 6 zeros, times parentheses, 0.025 over 360, close parentheses, divided by parentheses, parentheses, 1 plus 0.025 over 360, close parentheses, raised to the 14,400 minus 1, close. And so, is anybody else, do you want this to the nearest cent or to the nearest dollar?
It's the nearest cent.
So to the, and again, we have to round up to the nearest cent. Is anybody else getting that they need $40.42 a day?
Yes.
Yep. That's what I got.
So of that $1 million, how much of it is our own money? Well, we're paying that $40.42, 14,400 times. So we're contributing, what is that? $582,048.
That's what I got.
And so interest wise, we're of that $1 million, if we subtract what we put in, the 582.48. We are earning $417,952 interest. How fun is that?
Thank you.
So $40 a day, that might be a bit of a stretch to come up with, but maybe a little bit less than $40 that when you begin. And then when you are out of school and working at your full-time career, you can think of setting
Yeah.
a little bit more than $40 to balance it out.
Mm-hmm.
But this just this general idea of, wrapping your minds around setting aside money for savings, all right? The other part that's in the section of the textbook that we're not looking at this semester because again, I wasn't sure how much time we would have, so I didn't include it in the assignment this semester, is the idea of how the stock market works. And so if you're at all interested in that, this is from section, I think, 12.5. You can read about in the virtual textbook about how all of those crazy abbreviations on the stock page of the newspaper, what they all mean, and how just in general the stock market works. Okay?
Mm-hmm.
All right.
Thank
Now
you.
I've got that it is 10:50. Thank you for making up that problem. It was a really cool one. Let me stop recording.